bold text in blue is my Twitter handle, and I'm going to post the slides links there after this talk. And also, if you have any questions or comments or general feedback about this subject, feel free to reach me. And as I said, I work as a software developer at Vinta Software. We are a product consultancy company from Recife, Brazil, which works with our clients, mostly from the Bay Area and New York, to evolve the product using top-notch technologies such as Django, React, and UX techniques. We also love open source, so we have a lot of tools on GitHub that you can check at our organization. It's github.com/vintasoftware. We've got a playbook as well with all our processes and learning so far, so you can check it out on our website. It's pretty cool. And I just want to give a disclaimer, a quick one. This talk is about Django, so I assume you already have some knowledge about it, but it's just some basic concepts because we're going to cover a lot of subjects today. If you know some concepts, it's going to be easier for you to understand. And OK, onto the topic. We're going to talk about query expressions today. But first, I want to ask you all a question. Have you ever tried to fetch complex data in an application and got really confused? It's a rhetorical question. But it's happened a lot to me. But I can only imagine how many times it has happened to all of you here. And as I use Django in my day-to-day, I thought some time ago that this framework is 14 years old. A lot of people have used it. And so it must have something to help me get whatever I want in the best possible way. So I've worked with applications that grew large over time, and with that, some context and business rules changed. And it became very common to create some redundancies along the way, and we ended up adding more fields in the database than we actually needed. And that's a reality of a lot of systems out there. And to mitigate problems like this, sometimes people follow paths such as caching or denormalization. And by the way, if you are interested in denormalization, the subject, there's a great talk about it by Flávio Juvenal. He's one of Vinta's partners. It's from the DjangoCon last year. Here's the title. But OK, if your application isn't really complex and doesn't need the advanced techniques like the mentioned ones, you don't have any excuse not to use the ORM. And we're going to learn why and how today. But we can't start talking about query expressions without introducing this powerful tool called ORM. As you may know, in Django, we have the ORM. It stands for Object Relational Mapping. For those who don't know, in few words, it's a tool to translate our most of the time relational database dialect into Pythonic objects named models, so they become more readable and manipulatable. And it has lots of useful things that we can use to search for something in our database, such as filter, which we're going to use a lot today. And with it, we have lots of abstractions that helps us to get our data much more easily than just writing pure SQL. But today, we're not going to talk about simple filters. We're going to dive into some concepts, such as QNF objects, database functions, conditional expressions, and present the many ways in which you can appease your advanced query needs with Python and nothing more. And all of that using query expressions, which are smart yet straightforward functions that can be used to compute values on query execution. So for example, you can do complex queries with OR statements, string manipulations, calculations, everything at the time Django hits the database. So this removes the necessity of having extra columns there and helps to generate readable and performant queries. So for instance, with a database of 500,000 records, to get people who were born in a leap year, instead of writing the SQL on top or maybe the naive code on the left, which run, by the way, in an average of almost 4 seconds, we're going to write the code on the right, which run in an average of 0.32. And for that, we're going to use the query expressions learned today. So to start with them, we need to understand a little bit more about Q objects, because they are the most common solution, and if you use Django, you must have used it a lot. They are usually the first contact one has with complex filtering, because this API is really not too difficult to understand. And they serve as an SQL encapsulator for queries with different conditions. So if you want to do queries with or statements or negative statements, or maybe both, Q objects are what you're looking for. So to start with a simple example, if you want to fetch people who were born in different generations, birth date is a field in our person model, by the way. We need to change the Q objects like this, passing each one of the ranges into a Q object and appending them, joining them using the ampersand, the vertical bar, sorry. And Django is smart enough to generate the SQL and filter everything for us. In case you want to add more conditions, it's possible to compose complex filters with Q objects as well. So remember our first filter by years? Now we've added another condition. So we could use that with a location filter. Location is a foreign field, which has a postal code field just for explaining. So this will filter by anyone who was born in one of these ranges and lives in California. To include more conditions, you can just include them in a Q object and use the operators vertical bar or ampersand, and it's gonna work smoothly. Just a tip before we proceed, because it's very extensible, complex filters with Q objects can get huge over time. So I know that some people say that good code is self-documenting, but it's advised to comment just a little bit, so you won't lose time trying to understand how that code you wrote a year ago works now. And as I said before, you can add as many filters as you want. So I've added blood type, job, and etc. So moving on, let's say that our application has an interface that users can search stuff. And the user can input whatever they want, and we're going to search for all possible fields and return the result to them using insensitive contains. That will work, but what if our user just want to search for the first name, for example, or job title? We can give our user the freedom to search for what fields they want. And that's possible if we mount a Q object before passing to the query. Using an approach with some ifs and Q objects, with Q.add, I mean. There are other approaches for that, but I just would use this one because it's simpler. So it will check which fields the user has selected in our interface, for example, and it will add their conditionals accordingly. So, for example, email field wasn't included in our search, so it won't be added to our filter, so as you can see. And at the end, you're just going to pass the Q object you mounted to the query, the filter, and it's going to search with the correct parameters. So it's going to find, for example, people with Mark as name, first or last, people which work as chief marketing officer, trademark, lawyer, and so on. And just a quick off topic, if you are more familiar with SQL and want to see what your database reads, you can print your query.query, the yellow arrow, and you're going to see the output below. In this case, for Postgres databases, and I've omitted some info just for simplification. And if you also want to format it, you can use a lib called SQL parse. It's a Django dependency, so it already comes when you install it. The point is, it's important to understand that at the end, everything is SQL. It took me some time to realize that. And as you can see, that Django handles everything for us, so we don't have to worry about writing super long SQL statements, which is not quite the case now, since our examples are very simple, but that becomes a reality once your application scales. Another base resource, which is very useful for queries, is called f-expressions, or f-objects. And to start with it, I want to show an example first. According to the American Red Cross, people can donate blood every 56 days. So I have our person model here with two fields, less donated and can donate on. And theoretically speaking, when less donated gets updated, we should update can donate on with 56 days ahead. And if you want to get people who can already donate to, for example, send an email to them, you could do something like this using this filter. less than or equal, time zone now. But what happens if the lesson native field is updated, but candidate on is not for any reason? How can we assure that this field has a reliable value? It's critical because we can't let people donate blood before the 56 days. So this code could cause serious inconsistencies. And to solve this problem, you have to use F objects because the value would always be correct because it will always be calculated on query execution. So F objects are used when you want to filter to reference model fields in a query without having to load them into memory. So you can do basic arithmetic operations with them. So for example, as I said, people can donate blood every 56 days. So to know when they can donate again, you can annotate the date using F to get the last donated value and increasing 56 days using time delta, for example. And then you can filter by the annotation. And in case you want to send like an email, as I said, to people, reminding them that they can donate again. And without it, you would have to write the raw SQL or filter with Python, which, as we saw in the beginning of this talk, decreases performance a lot because there's no such way to do operations like this in an effective way without using F in this case. We can also use F to do operations with different fields or to reference annotations. So from our last example, we annotated the exact date in which people can donate blood again using F and time delta. Now we're going to use F for everything. In this example, we run a blood bank and want to see to check how many bags are missing for our goal. And to do that, we can use an annotation of how many blood bags we already have. We can annotate the remaining bags missing for our goal using the F to reference the annotation we just did, and using a basic arithmetic with another field. So we're going to get exactly how many bags are missing for our goal, in this case, 500. And in the previous example, we've used F with two fields, but both were integers. In case we want to do operations with different fields, with fields of different types, we have to use something called expression wrapper. Because when you try to, for example, in our event model, sum its duration, which comes from a duration field, so it's a time delta, and a datetime field, Django throws a field error. So that's solved by wrapping our sum in an expression wrapper and setting the output field as a datetime field. So for example, if we have an event that starts today and has a duration of one field, the end zone should be tomorrow, same time. And at the end, we can mix F and Q objects all together to create unique queries. So in this case, we want to get people whose first name equals their last name and don't have Mark in their job titles. I have nothing against marks, okay? It's just an example. And as you can see, query expressions are very modular, just like some other resources that we're going to see soon. And okay, we've seen how to create filters, how to access and do operations with different fields. And now we're going to learn how to manipulate data with database functions. They are basically abstractions to help us to access database level functions, as the name suggests, directly. So for example, to count how many pets we have in our system, we have to use a function called count in an annotation. And that, just like most of the database functions, will be available using the name of the field you pass dunder, which means double underscore, the database function name. So in our example, we have type dunder count. And at the end, we have the distribution of pet types correctly. And there are more than 50 database functions, so we won't have time to cover them all today, but I'm going to talk about some of them and we'll see how useful they are. Database functions used with annotations are a very important resource, especially when performance is required. Another good example, we have our person model that you already know about, and it has two fields, first name and last name. And I want to search for a string in their full name. So adding a property would do the trick. And I just have to load. I would just have to load the person model and do the search, as you can see on the right. But there is a problem here. Since it's a property, it cannot be used in queries. So if I want to do a searching everybody's name in the scenario, I would have to load everyone into memory, and that's not what I want. And a solution to that relies in a null function called concat, for example, which stands for concatenation. So you can annotate the full name by calling this function with the field names, first name and last name. And just so you know, I had to put a function called value there, because if I hadn't, Django would try to find a field with empty string, with the name as empty string as a name, and it would throw an error. And after annotating the full name, I can use as many string lookups as I want. Inconsistencies, exact, something like that, and it will work. And just so you see, I wanted to bring this GIF to compare our solutions with the full name property and the annotation. At first, it's very fast, as you can see, but as I add more zeros to my limit, the worse it gets. So last frame was 500,000 records, and took about 4 seconds to load everyone's full name. In a big application, such as the one I work on, that's too long for the end user, and we cannot let this happen. And back with our full name example, just a tip. To avoid calling the whole annotation every time and importing everything, every time you want to annotate the full name, you can add this annotation to a query set or a manager if you want. We're going to use query set just for simplification. And then you can add the query set to the model using dot as manager. And now you don't have to worry about. Whenever you have the person model imported, you can annotate the full name by just calling a method, the annotate full name method. And another great example is a database function called coalesce. It returns the first non-null value given at least 2 field names. So for example, our person model has a field called nickname, and if they have one, I want to show it instead of the first name field. But if they don't, I just want to show the first name. And that works, but there's a pitfall. As a sec, coalesce returns the first non-null value. So if anyone has, for some reason, an empty string as a nickname, it's going to return, the annotation is going to return an empty string, and that's not what I want. And a solution to that, for that, is using another database function called nullif. It was added in Django 2.2, which accepts 2 expressions and returns none if they are equal. So in our case, we compared our field nickname with an empty string value. Again, I had to use value here because Django would try to look for our field called empty string. And OK. You've seen that we can do some conditional queries with nullif, for example, in our last example. But if we want to do some complex queries with just one turn, we use conditional expressions. They allow you to use conditional logic in queries. That means filters, updates, annotations, and such things. So without them, you would have to use Python, and the code would be bigger. So for our example, I said that people can order things. And let's give them discount if they are loyal customers. And using the order for today, let's get if the user joined our system this decade. In this case, we're going to give them a 20% discount. In case they joined between 2000 and 1995, we're going to give them 40% discount. And just so you know, it's 0.8 and 0.6 because the discount is subtracted from the full price. It's intentionally naive. We can understand this code, but it's not really easy to read. And a better way to do it would be using case and when expressions. Case is very useful when you want to do ifs, elifs, or elses in your query with little to no time, And it's better because the value is calculated at the time the query is executed, so it will be much faster. And if you want, you're going to be able to filter this query at database level, hitting it only once. And as it's an annotation, we're not going to lose the original order total. And at the end, we can mix everything we've learned today to annotate if someone's birth year is a leap year, for example. And just to give some context about how to calculate a leap year, it's a bit difficult. It should be exactly divisible by 4. If it can be exactly divisible by 100, it's not unless it's exactly divisible by 400. It's a bit tricky, but just so you get the idea. So we start by doing the needed annotations with database functions, cast to transform the value from extract year to an integer, because extract year at database level returns a double precision floating point. I've never personally used that, but if someone here knows about it, I'll be happy to learn. And F objects to do the operations with the reference annotations to get the modulus of the integer. Then we're going to use the previous annotations into our conditional expressions with Q objects. And in the when, the second line, we define false by default. And we do all the math to make it true. And finally, we filter by the annotation we just did. And from now on, it's just testing if our annotation is true. So at the end, we'd have done calculations and conditionals just hitting the database once. These are the references that helped me, inspiring me to do this talk. The links are going to be on the link, my slides link on Twitter. And thank you. That's it. If you want, you can access this talk in this link. Okay. Any questions? Do we have time for questions? Yeah? Okay. Okay, you can contact me through Twitter after. Thank you.